Welcome back, everyone. Today, we're going to be diving deep into generative AI with C++.
Ooh, interesting choice.
It is, and we're going to explore how this, powerful language can be used to build AI that can create things.
Create things.
Yeah, like images, text, music.
Really?
Yeah, all by learning patterns from existing data.
Right. So it's not just about like recognizing patterns,
Yeah,
it's about actually making new stuff.
exactly. And while, you often hear about Python being used for AI, C++ brings, uh,
It brings something different. It's like, well, if Python is the Swiss Army knife of AI,
okay.
C++ is the finely tuned engine.
Ooh.
That gives you that raw power
Yeah.
and control for some of the really demanding AI tasks.
I like that analogy.
Yeah.
The Swiss Army knife versus the engine.
Yeah, exactly.
So we're talking about building AI that can imagine original artwork, write compelling stories, or even create these realistic simulations, and all with C++ is like our tool.
That's right. And what's exciting is C++ lets us like squeeze every ounce of performance out of our hardware, especially when we're dealing with those like super complex computations in deep learning.
So that's where the speed and efficiency of C++ really come into play.
Exactly. It makes a huge difference in how fast our AI models can learn
Right.
and how much data they can actually handle.
That makes sense. I mean, C++'s reputation for speed and efficiency it's almost legendary, right? It's like having that direct line to your computer's processor,
Oh, I love that.
giving you the ability to really fine-tune everything for maximum performance.
Yeah, it's true.
And when you're dealing with these massive amounts of data and the complex calculations involved in AI, that kind of performance boost it's essential.
Absolutely. And plus, C++ has this rich ecosystem of libraries specifically for AI development.
Oh,
So
okay.
like TensorFlow and Caffe, they give you those pre-built functions and
So
tools
it makes things easier.
way easier, yeah, to build and deploy these sophisticated AI models.
So it's not just about raw power then. It's about having the right tools for the job.
Exactly. It's like having an expert mechanic handing you the perfect wrench for each specific task, you know?
Yeah.
They take care of all the heavy lifting and you can focus on the creative stuff,
The fun stuff.
the fun stuff.
Before we get too deep into the technical side, though, let's take a step back and make sure we're all on the same page about what machine learning actually is.
Okay.
So imagine teaching a computer to learn from data without explicitly programming every single step.
Right.
That's the essence of machine learning. It's like showing a child a bunch of pictures of like cats and dogs and letting them figure out the difference on their own.
That's a great analogy.
Yeah. So, and this learning can actually take different forms, right?
It can.
There's supervised learning,
Yeah.
where you give the algorithm labeled data,
Like those pictures in cats and dogs.
exactly, with their names attached.
Right.
And it learns to predict those labels for new unseen data.
It's like having a teacher, right?
Yeah.
Guiding the algorithm, showing it the right answers.
Helping it along.
Exactly.
Okay, and then there's unsupervised learning, where the algorithm gets unlabeled data.
Ooh, tricky.
Yeah, and it has to find patterns and relationships on its own. It's
Yep.
like giving someone a jigsaw puzzle without the picture on the box.
I love that.
And just, letting them figure out how the pieces fit together.
That's unsupervised learning for you.
It is. So it's more about exploration and discovery,
Yeah.
letting the algorithm kind of find those hidden structures and insights that we might not even know exist.
That we don't even know exist.
So you've got the foundations of machine learning in place.
Yes.
But to really kind of unlock the potential of generative AI, we need to step into the world of deep learning.
Okay.
Think of it as machine learning on steroids.
Ooh, I like it.
Deep learning utilizes these artificial neural networks,
Okay.
which are these complex structures inspired by the human brain.
Like our brains, but in code.
Yeah. So these networks are made up of layers of interconnected nodes, and each connection has a weight associated with it, kind of like the synapses in our brains.
So it's like mimicking how our brain learns.
It is. So instead of having just a single layer of processing, we have multiple layers stacked on top of each other.
Right. Which allows for way more complex learning.
Much more nuanced learning.
Exactly.
And this layered structure allows deep learning models to extract hierarchical features from data.
Okay.
So think of it like recognizing a face. The first layer might detect simple edges and lines,
Okay.
and the subsequent layers combine those edges and lines to recognize shapes like noses and mouths,
Right.
and eventually the entire face.
The whole thing.
Yeah. It's like building up an understanding from, simple building blocks to increasingly complex concepts.
Yeah, that's exactly how it works.
And this is what allows deep learning models to tackle these really complex tasks,
Yeah.
like image recognition, natural language processing, and, of course, generative AI.
Exactly. And the more layers you add, the more sophisticated the model becomes.
Right,
Like,
but that also demands a lot of computational power.
it does, and that's where C++ comes in.
Yes. Back to C++.
Its ability to, efficiently manage memory and execute code so fast makes it perfect for building and training these really complex models.
And it's not just about speed, right?
No, it's not just about speed.
C++ gives you that, granular control over how your code interacts with the hardware.
Exactly.
Which is super important, especially for things like GPU acceleration.
Yes.
Where you can leverage the parallel processing power of graphics cards to train AI models so much faster.
It's like having a team of workers instead of just one.
Right.
You can get things done way faster.
Exactly.
And C++ allows us to, seamlessly integrate CUDA into our deep learning projects.
That's that platform specifically designed for parallel computing on GPUs, right?
It is.
Yeah, I've heard about it, especially in the context of AI.
Yeah, so we can train models that would normally take days or even weeks in a fraction of the time.
That's incredible. And with C++, there's powerful libraries like TensorFlow and Caffe. We have all the ingredients.
All the ingredients.
To build and train these really sophisticated deep learning models.
We do. So we've got the speed and efficiency of C++ HALA, the power of deep learning, and there's amazing libraries. Now let's get to the heart of it all. Generative models.
Okay, now we're talking, these are like the artists of the AI world.
They are.
So what makes them different from other types of AI?
Well, they're not just about analyzing data, they're about creation.
Okay.
Imagine training an AI on thousands of paintings.
Okay.
A generative model could then create entirely new paintings in a similar style, even mimicking the brushstrokes of the original artists.
So it's not just about recognizing those patterns. It's about understanding the underlying principles and then using that knowledge to create something totally new.
Exactly. Like learning the grammar of a language and then writing your own poems and stories.
That's incredible. I'm already starting to see the potential here, but how do these generative models actually work? What's the secret sauce behind the AI magic?
Well, two of the most powerful techniques are VAEs, or Variational Autoencoders, and GANs, or Generative Adversarial Networks.
GANs, I've heard of those.
Yeah.
They sound a bit more adversarial.
They are, yeah. Each has its own way of creating new data.
Okay, so let's start with VAEs. How do they capture the essence of the data they're trained on?
Okay, imagine you have a really complex image, like a photograph of a sunset.
Beautiful sunset.
Beautiful sunset. A VAE will try to compress that image into a much smaller representation.
Okay.
Kind of like creating a zip file.
So it's like distilling the image down to its, core elements.
Exactly. And then using this compressed representation, the VAE can reconstruct the original image.
The full sunset.
Full sunset, yeah.
Yeah.
But here's the cool part. We can tweak this representation, change a few things, and then decode it to generate variations of the original image.
So you could, change the colors of the sunset, add some clouds, or even turn it into a sunrise.
Exactly.
That's amazing. So VAEs are like these master distillers, capturing the essence of data and then letting us remix and reinterpret it in these really cool ways.
Exactly.
Okay, now let's talk about GANs, those adversarial networks.
All right, so GANs work by pitting two neural networks against each other.
Like an AI battle.
It is. You have a generator network, which tries to create fake data.
Okay.
And a discriminator network, which tries to tell the real from the fake.
So it's like a constant game of cat and mouse.
It is. The generator's trying to fool the discriminator, and the discriminator's trying to catch the generator.
And they both get better over time.
They do. The generator learns to create more realistic fakes, and the discriminator gets better at spotting them.
So it's like an AI arms race, pushing each other to improve.
It is, and that's what makes GANs so powerful for generating high-quality images, text, videos.
Wow, this is amazing. So we've gone from the basics of machine learning to these complex neural networks and these really cool generative models.
Yeah.
But I'm curious, how do we actually build these models in C++? I mean, we know it's all about performance.
Right.
But where do we even begin?
Okay, so first, you need to set up your development environment.
Okay.
You'll need a C++ compiler, like GCC or Clang, which translates your code into instructions your computer can understand.
It's like the translator.
Exactly. Then you'll want an IDE, like Visual Studio or Client. These are like workshops for writing and testing your code.
This is not just about writing the code. It's about having a space to experiment.
Right, exactly. And AI projects can get really big with lots of files, so using a build system like CMake can really help.
Keep it all organized.
Exactly.
So we've got our tools, but now let's talk about C++ itself.
Okay.
What are some of the key concepts we need to know for AI development?
Well, C++ is all about efficiency.
Right.
So understanding how memory is managed is crucial.
Especially when dealing with those large AI datasets.
Exactly. And then there's object-oriented programming, which is a way of organizing your code.
Make it more manageable.
Exactly. It makes your code reusable, which is so important when you're building complex AI systems.
Right, and we can't forget about the C++ standard library and the STL. Those are full of pre-built functions.
Those are lifesavers. They save you so much time and effort.
So we've got our C++ environment set up. We understand the basics of the language, and we have access to those powerful libraries. Now, let's talk about the core of AI, those machine learning algorithms.
Right.
We already talked about supervised and unsupervised learning.
Right.
But can you give us some concrete examples of algorithms we might use for generative AI?
Sure. Let's start with supervised learning. For predicting continuous values, like the price of a house, linear regression is a good one.
Okay.
And for classification, like figuring out if an email is spam, logistic regression is popular.
So linear regression is like drawing a line through data to find the trend, and logistic regression helps us categorize things.
Exactly. And then there are decision trees, which are really easy to understand.
Decision trees.
They work by splitting data based on different features, like a flowchart.
So a series of yes-no questions leading to an answer.
Exactly. Now, for unsupervised learning, clustering algorithms are key.
Okay.
K means clustering groups' data points based on how similar they are.
So like grouping customers with similar buying habits?
Exactly.
That's cool.
These are just a few examples, but there's a whole world of algorithms out there.
And C++ lets us experiment with all of them.
Exactly.
This is all so exciting. We've covered so much already, from C++ to neural networks and these amazing generative models.
We have.
But before we get into the specifics of how those models work, we need to talk about preparing our data.
Ah, yes, data prep.
Yeah, forget about that.
We can't just throw raw data at our AI models and expect magic. We need to clean it up and prepare it.
Like prepping ingredients before cooking.
Exactly.
You wouldn't just throw raw vegetables into a pot.
No, we need to wash, chop, and season them first.
Exactly. And that's what data preprocessing is all about. We handle missing values, scale our features, and encode things properly.
Make sure it's all ready for our models.
And this is another area where C++ shines.
It is. C++'s efficiency lets us process huge data sets quickly, and its libraries give us the tools for data manipulation.
So it's not just about the algorithms. It's about having the right tools to prepare the data for those algorithms.
Exactly. And this data preparation step can take a lot of time.
But it's crucial, right? Garbage in, garbage out, as they say.
Absolutely. The quality of our data will directly impact how well our models perform.
So we've laid the groundwork.
We have.
We've got C++ here, we understand machine learning, and we know how to prep our data. Now, let's finally step into the world of deep learning and neural networks.
Let's do it. Neural networks are the brains behind deep learning.
Inspired by the human brain.
Exactly.
So they're made up of those interconnected nodes, or neurons, organized in layers.
Right.
And each layer does its own processing.
The input layer takes the data, the hidden layers process it, and the output layer gives us the results.
And what are some popular libraries for building these in C++N?
TensorFlow, developed by Google, is a popular choice because it's very scalable.
Okay.
PyTorch, from Facebook, is known for its flexibility, especially for research.
Okay.
And Caffe, developed at Berkeley, is great for image processing tasks.
So we choose our library, define our network, and then we train it. What does training actually mean in deep learning?
It's like coaching an athlete. You give the network data, adjust its parameters to minimize errors, and repeat until it gets good at making predictions.
Practice makes perfect.
Exactly. And C++ gives us the speed and control to do this efficiently.
And we can use GPUs to speed up training.
Exactly.
This is fascinating. We've gone from the basics of C++ to the complexity of neural networks. But now I'm really excited to dive into those generative models, VAEs and GANs.
Let's do it.
So let's start with VAEs. How do they work?
VAEs learn efficient representations of data. They have an encoder that compresses the input data
All right.
and a decoder that reconstructs it from that compressed form.
Like squeezing an image into a tiny file.
Exactly. And the magic happens in that compressed form where the VAE learns to represent the data in a smaller dimension.
While keeping the important features.
Right. And we can generate new data by changing things in this compressed form and decoding it.
So we could train a VAE on faces and then generate new faces by tweaking things.
Exactly. It's like playing with the building blocks of what makes a face.
That's incredible. Now let's talk about GANs. We've talked about their adversarial nature, but can you walk us through how they work in C++, Guy?
Sure. Remember, GANs are like a game between two networks. The generator tries to create fake data, and the discriminator tries to tell real from fake.
The cat and mouse game.
Exactly. And they both get better over time.
Leading to some amazing results.
Yes. GANs can create realistic images, music, videos.
The possibilities seem endless. Okay, so we have these models, but how do we actually use them in the real world?
C++ is key here. It allows us to optimize these models and integrate them into systems.
So we could build a generative AI that runs on a smartphone, creating personalized content.
Exactly. And C++ gives us the control to make sure it runs smoothly, even on devices with limited power.
This is all so exciting. I feel like we've only scratched the surface of generative AI with C++.
We have. And in the next part of our deep dive, we'll explore even more cutting-edge techniques and applications.
I can't wait. We've been talking about using C++ to build AI that can generate images, music, video, all sorts of creative content.
Yeah, it's really incredible.
But what if we could go even further? What if we could teach AI to understand and even generate human language?
That's a whole other challenge. Language is so complex.
It is. It's full of nuances, context. How could a machine ever grasp all of that?
That's where natural language processing comes in, or NLP for short.
NLP.
It's all about enabling computers to understand, interpret, and even generate human language.
So it's like bridging the gap between how we communicate and how computers process information.
Exactly. NLP involves a ton of different tasks.
Like what?
Well, there's basic things like breaking down text into words and sentences.
Okay.
But also more complex stuff like sentiment analysis, figuring out the emotional tone of a piece of text.
So like you could analyze a tweet and know if someone's happy or angry.
That's the idea.
That's pretty cool. I can see how that would be super useful.
It has huge implications for like social media monitoring, market research, understanding customer feedback.
Yeah, tons of applications. So how do we actually do NLP with C++ MIT?
Well, first we got to prep the text data, convert everything to lowercase, remove punctuation, get rid of common words that don't really mean much, like the or and.
Like cleaning up the raw ingredients before you start cooking, right?
Exactly. Then we can start using techniques like word embeddings.
Word embeddings. Haven't heard of those.
Okay, imagine representing each word as a point in a multidimensional space.
Multidimensional space. Whoa.
Words with similar meanings would cluster together,
Yeah.
and words with opposite meanings would be far apart. That's what word embeddings do. They capture the relationships between words.
So happy and joyful would be closer than happy and sad.
Exactly. And we can use algorithms like word2vec, which we can implement in C++A, to generate these embeddings.
So we can build a model that understands how words relate to each other.
We can.
What kind of NLP models can we build with that?
Well, sentiment analysis is a good example. We could build a model that takes some text, like a movie review,
Okay,
and predicts if it's positive or negative.
cool. What else can we do?
Machine translation is another big one. Imagine a system that automatically translates text from one language to another.
That would be incredible, breaking down language barriers.
Exactly. And it's all possible with C++ and its ability to process language at a deep level.
This is amazing. We can generate images, music, understand language. But what about, like, robots and self-driving cars?
Ah, you're thinking about how AI interacts with the physical world.
Exactly. How are these models used to create machines that can operate in the real world?
That's a key challenge, training these systems in realistic environments. Building physical testing grounds is super expensive and time-consuming.
Right, so what do? Just let the robots loose in the real world and hope for the best.
That wouldn't be a good idea. Too risky. That's where generative AI comes in again.
Wait, so we're talking about using generative AI to create virtual worlds for robots to train in.
You got it. We can create realistic simulations of cities, traffic, pedestrians, even changing weather.
It's like a video game, but for training robots.
Exactly. It's a safe and controlled way to test and refine algorithms, expose them to way more scenarios than we could in the real world.
Makes sense. So how do we build these virtual worlds?
C++ WAN, of course. We use it to define the physics, the behavior of objects, the visuals, and generative models help us create realistic content.
So we're making virtual movie sets with AI-powered extras.
That's a great way to put it. And all of this ties back to reinforcement learning.
Reinforcement learning, that's about letting robots learn through trial and error.
Right, exactly. We give them goals and let them learn in these simulations. We use C++ to implement those learning algorithms.
This is blowing my mind. We're creating entire realities for AI to learn in.
It's really amazing what's possible these days.
It is. But as we build these increasingly sophisticated systems, we need to be responsible.
Absolutely. AI is powerful, and we need to make sure it's used ethically.
So it's not just about the cool tech, it's about using it for good.
Exactly. We need to think about fairness, transparency, making sure AI benefits everyone.
Okay, I'm with you on that. Now, what about federated learning? I've heard that term thrown around. What is it?
Federated learning is a way to train AI models on data from multiple devices without actually sharing the raw data.
Whoa, so like training on data from tons of smartphones, but without any privacy concerns.
That's the idea. Each device trains its own local model, then shares encrypted updates with a central server.
So it's like a team of scientists working together, but without revealing any confidential patient data.
Exactly. It's huge for privacy-sensitive applications of AI.
Can we build these federated learning systems with C++ Bol?
Of course. C++ has the tools for secure communication, distributed computing, all that good stuff.
So C++ really is the Swiss Army knife of AI development.
It is. It gives us the power to build the future of AI, one line of code at a time.
I love that. This has been an amazing journey so far. We've learned about C++, machine learning, deep learning, even federated learning.
And we've only scratched the surface. There's so much more to explore.
It's been quite a journey exploring the world of generative AI and C++.
It has.
We've seen how it can create, well, practically anything.
It really feels like there are no limits.
From art and music to even powering self-driving cars.
Amazing.
And C++ provides that foundation, the speed and control.
It's the backbone of it all.
To handle those complex tasks, especially in, deep learning and these generative models.
Yeah, and those libraries like TensorFlow and Caffe, they give us the tools.
They're like our AI toolkit.
Exactly.
But as with any powerful technology,
Right.
we need to be careful.
Absolutely.
We've talked about responsible AI, ethical AI.
It's crucial.
It's not just about the cool tech. It's about how we use it.
And how it impacts society.
Yeah.
We need to make sure it benefits everyone, that it's fair, transparent.
Accountable.
Yes, accountable.
So as we wrap up, I want to leave you with something to think about.
Okay.
We've seen how generative AI can create, well, practically anything, right?
Yes.
But imagine an AI that could not only create, but also explain its process.
Explain its process.
Like, tell us why it made certain choices, what inspired it, what emotions it was trying to evoke.
Wow, that's a really interesting thought. Like having a window into the AI's creative mind.
Exactly. It could change how we understand creativity itself.
That's true. It raises questions too. Would we consider it truly creative or just a really good mimic?
Big questions.
Yeah, and I don't think we have the answers yet.
That's what makes this field so fascinating. We're in uncharted territory.
Pushing the boundary.
Exploring those big questions about intelligence and creativity.
And with C++ came, we have the power to build that future.
One line of code at a time.
One line at a time.
And that's where we'll leave it for today. Our deep dive into generative AI with C++.
It's been a great discussion.
It has. Thank you for joining us on this exploration of cutting-edge AI and the power of C++.
Thanks for having me.
And to all our listeners, keep exploring, keep learning, keep diving deep into the world of AI.